In this video we're going to introduce you to rotary machining. This is where we take one of the linear axes in the software and we wrap it around a cylinder. Now this is only applicable if you have a rotary axis attachment for your machine and you have a post-processor that's configured to run it. If you do, then what we're going to show you in the video here are various tools that we've got, first to help you set up the job, and then secondly some specialist layout tools for particular rotary applications. Let's go ahead and start a copy of the software to begin. It's essential if you're planning to use the software to create output for your rotary axis on your CNC that you use a special job setup form. To access this, we go up to the Gadgets drop down, come down to Wrapping, then from the side menu we choose Wrapped Job Setup. Here you can see it'll open this special form, and this will ask us all the information that the software needs in order to set up the right size job, but more importantly to know how that job is being wrapped. The first bit of information we need to tell the software is the length of the part that we plan to machine. So in this case I'm going to set up a job which is 12 inches long. Next we need to tell it the diameter, and in this case I plan to use a cylindrical piece of stock which is 3 inches in diameter. I say the units are specified here, whether you're working in imperial or metric. Next, and very importantly, I need to tell it the cylinder orientation. This is going to depend on how your rotary axis is set up on your CNC. In some cases you're going to have a linear x-axis and then the rotary part of it will be wrapping the y values, and in other situations you're going to have a linear y-axis and then the wrapped values will be going along the x-axis, and the diagrams here are pretty self-explanatory. For this example I'm going to work with my x-axis as linear and wrapping the y values. I'm going to set my drawing origin to be in the lower left, and then I need to specify the Z origin. Now that can either be on the top or the edge of my cylinder or in the center of it. Now generally it's much more accurate to use the option to use the cylinder axis or the center of the cylinder as the Z0. And this is the equivalent of setting the Z0 up to be the bottom of our material as we would normally do the material setup in the software. Lastly, we need to tell it what kind of wrap we're doing. We have the option of a simple cylindrical wrap, which is the equivalent of taking our cylinder and just literally opening it out where the join is going to be a straight line. Or we can do a spiral wrap, which as you can see here is going to be the type of thing we would do if we had a repeating decorative motif spiraling up and around our cylindrical part. In this case we're going to go for a simple cylindrical wrap and hit the OK button. Now the software has created a job which is 12 inches long in the x-axis, which is what we specified, but if we look at the height of the job down in the bottom left hand corner here, that's been defined as if it was the circumference of our cylinder. So basically all it's taken is this imaginary 3-inch diameter cylinder and unwrapped it to create a flat part from that. And everything we do in the software is effectively going to be calculated in a flat environment, and the only time that this output will actually change into rotary is when we use the post processor that has that ability to do that. Now we do have the ability inside the software to visualize some things in a rotary environment, and we'll show you how to do that. But again, just to reiterate, everything we do in the software is effectively done in a flat environment, and only when we post-process that is it actually transferred into moves that will run as a rotary job on your machine. Now the depth of cut here, or the depth of material rather, has been defined as half that diameter, because again if you imagine this unwrapping, we've effectively got a strip of 1.5 inch thick material, and when wrapped up that creates a 3-inch cylinder. So let's start by creating some simple engraved text and showing you what that looks like in this rotary environment. Let's come up and click on the icon to draw text within a vector box. If we have no vector selected, then that will just pick up the dimensions of our job. I'm just going to click here and hit A on the keyboard to go up to the fonts beginning with A and pick the Arial or Arial font there. I'm just going to set that to be in the center. I'm going to take the default values, normal, no stretch and no horizontal stretch here, and let's go ahead and type wrapped Rotary text and hit apply and close. So that's just created some simple text for us. Now let's click on the icon to minimize the drawing tab and maximize the Toolpaths tab. Let's just check our material setup. Now this has been effectively already set up for us by the wrapped job information that we input. So we've got the Z0 at the bottom of the block, which is the equivalent to the center axis of our cylinder. We have 1.5 inch material, which is the equivalent of our 3 inch diameter when wrapped around there. Datum in the lower left, and I have no model in this at the moment, so that's irrelevant to us. The one thing I do need to be aware of is because we've effectively set Z0 at the bottom of the block, my home position needs to clear the thickness of my material. So I'm going to set that to be a value of 1.75 and hit OK. Now if you are planning to actually cut this part yourself, then it's very important that all the settings you use are appropriate for your particular machine, the tooling that you've got available and whatever material that you plan to use. Not only that, of course, you need to make sure that your rotary axis orientation is correct for how your machine's set up as well. Now for the toolpath, I'm just going to select a simple pocket. So we already have the vector selected. Click on the pocket icon there, and I'm going to set the cut depth for this to be 0.1, and I'm going to select an 1/8 inch end mill. So if we don't have one of those, I may need to just quickly copy a tool there and then edit the value for the name and the diameter. Just hit apply and OK. I'm not going to worry about any of the other values in here. Just going to do a very simple pocket toolpath. Go ahead and hit calculate. Now you can see that that has automatically opened the preview toolpaths window as we'd expect, and it's showing me that toolpath in the standard 3-axis environment. And at this stage it's possible for me to preview that using the material block and see how it's going to look, make sure I'm happy with the toolpath as I say, in this 3-axis environment. Now we do have the ability in VCarve Pro and Aspire to visualize this in 3D. In Aspire I can actually preview this as a solid object like we are here, just without any toolpath colors. In VCarve Pro I'm limited to only previewing this in what we'd think of as a wireframe environment. So let's reset the preview here and hit close. I'm just going to switch on the toolpath so that that's visible. And in order to view this in a rotary environment in VCarve Pro, what I need to do is just switch off the shaded view. So I'm going to go to View and uncheck Color Shaded View there. Now I can come up to Toolpaths, go down to Toolpath Drawing, and you can see here I have the option to choose to pick wrap Y values around the X axis or wrap X values around the Y. And that'll depend on how I set my job up. We chose our job setup to have a linear X axis wrapping the Y values, so if I choose that, we'll see what that toolpath is going to look like when it's actually wrapped around the cylinder of the size that we've specified. Now that can be a little difficult to visualize, so we can help ourselves by going to View and Draw Material Block, and that's just going to draw a wireframe view of what our material block looks like. Now if we view down the X-axis, we can see, if we zoom out, how that toolpath is being machined into our cylinder, and we can look at that from an angle if we want to rotate the view. Something else that may help when visualizing this is to switch off the rapid moves. That doesn't mean that they won't be there, it's just purely for visualization. To do that we go up to View, Toolpaths rather, Toolpath Drawing, and then we can uncheck Draw Rapid Moves there. So if I switch that off again, that's just to make it a little bit easier to see. It hasn't got rid of the rapid moves, it just makes it easier for me to interrogate what's happening with a particular toolpath. Now just to reiterate, what we're looking at here is just a visualization of how this will be when it's wrapped. Internally within the software, it's still thinking of this as a 3-axis toolpath, and only when we use the appropriate post-processor will this be output in such a way that the code will be possible to cut on a rotary machine. Now here we've done a simple 2D toolpath, but it's possible to wrap any type of toolpath in the software. So we could come back to this if we want, perhaps delete the toolpath we've created there. From the 2D view with the vector still selected, perhaps I'd choose to do a V-carving. Now if we click that, I'm going to get a warning because the software has to be in the normal 3-axis view for us to allow us to calculate toolpath. So it's asking me if I want to switch off the wrapped toolpath drawing view. I can hit yes so that it's automatically done that in the background for me, and now I can just take that text with a 90-degree V-bit and we'll just hit calculate. So again, we're back in the normal 3-axis view. If I wanted to at this point, I could switch back on our color shaded view and I could preview that to make sure that it looks okay in 3-axis. If I reset it, come back to view, switch off the color shaded view again, switch on the visualization for that. Once more we can go to toolpaths, toolpath drawing, and wrap Y values around, and now we can take a look at what that toolpath will look like. So this is a V-carved toolpath, so we can see the tails there coming down and that the toolpath is being wrapped around the cylinder there so that we'd get V-carved text on our cylindrical part. Now notice the rapids are still switched off. If I wanted to see those again, then we'd have to come back in here and switch them back on. I'm happy with them switched off at the moment though, makes it a little bit easier to see what's happening. Again, just to reiterate, we're working in VCarve Pro here, which is why we're only able to visualize this with a wireframe. If you are working in Aspire, then you can use the standard solid block preview as you can with the 3-axis toolpaths. Let's go ahead now and just close the preview form there, and at this point I'm ready to actually save this toolpath out in the Rotary format for my machine. Now you have to make sure that you've got a post-processor that has the rotary moves in it that has been configured for your particular machine tool. If you don't, then you'd need to talk to your manufacturer about that, or you can send an inquiry through the Vectric support website, support.vectric.com, and then perhaps inquire if there's a post-processor that supports your machine. Assuming we have got a post, we can just select the file we want to output, click on the Save Toolpath icon. I'm going to click here and I'm going to hit M on the keyboard to go to the post processors beginning with M, and from here I'm going to look for one that's got the word wrap in it, and that's just a signifier that this is a post processor that will allow me to create rotary output. Now I need to match this up to the orientation that I've got for my job, and in this case what I chose to do is wrap the Y axis around the cylinder. So I'm going to wrap, here it says Mac 2/3 wrap Y to A, so it's telling me that the Y coordinates will be wrapped to A coordinates, which is just one of the standard designations for a rotary output. If I select that and I hit save, the software will show me this special window, and this is just so that I can check the parameters that I've used are correct before I go ahead and hit OK, and now I could give this file a name and save that, and that would be the output that I'd send to my machine with the rotary axis. So that's the way that we're going to post-process a file for a rotary machine if we have a post-processor that's configured to do it. I'm not going to save this at the moment. I'm just going to go ahead and hit cancel and close. At this stage, so we have a copy of this file in the project folder. If you want to take a look at it, I'm just going to come over and say File, Save As, and I'm going to call this file Rotary Text Toolpath. Just hit the save button there. Now I'm going to go ahead and close this and show you one of the other options that we've got for setting up rotary toolpaths. So again, I want to come up to Gadgets, Wrapping, Wrap Job Setup. It'll remember the last set of parameters I used in here, and I'm just going to take exactly the same set of values and choices and hit OK. So we've got the same size job again set up here, 12-inch cylinder, 3-inch diameter. Now I'm going to show you one of the other gadgets here that allows us to set up a particular type of vector or particular layout of vectors. If we come up to Gadgets, I'm going to come down to Wrapping again, and let's look at the fluting layout. So this is a way for us to lay out the vectors that allows us to create some straight lines that we can flute into a cylinder, as you can see here, and also if we want to add coves at each end of it. So in this case what I want to do is create 6 flutes. I'm going to offset them from the end by 1 inch, so offset from the start 1 inch, offset from the end 1 inch, and I'm going to create a cove at both the start and end as well. And at the bottom here it should just allow us to verify the information is the same as the job we've set up. That should match the wrap job setup parameters we used. If I hit OK, that's going to create a set of vectors for me there, And so this is purely just a layout tool to help me position these accurately. I could do this manually if I knew exactly how to create and work out all the values. This is just a quicker way to do it. Now we could take this set of vectors that we've got here. I can select all of those. Now you'll notice that they're on particular layers here, so it's helped me with the organization. I'm going to click on the icon to go over to the Toolpaths tab. Again, we could check our material setup if we want, but that should all be correct. And now I would come in and just profile these lines. I'm going to go down to a cut depth of 0.2 of an inch, and I'm going to select a ball nose tool, and I want a 1/2 inch ball nose tool. So I'm just going to copy that 1/4 inch tool there and make a quick edit so that we have a 1/2 inch tool, and give that an appropriate pass depth. Take the defaults for the rest of the values, hit apply and OK. And what I want to do is machine the center of the tool on these vectors. So I'm going to choose the option to machine vectors on. I'm going to take everything else as defaults and hit calculate. And that's just going to calculate a very simple 2D toolpath for us. Again, if we wanted to, we could preview that so we can see how that looks in 2D. But also, we could reset, close that, come up to the view, switch off the color shaded view, switch on the visibility of our toolpath, and go up to Toolpaths, Toolpath Drawing, and visualize that in the wrapped environment again. Notice the rapids are still switched off. The software will remember that until I switch them back on again. Now, if we are happy with that, we could go ahead and output it using the appropriate post-processor again. In this case, I'm not going to save the file, the post-processed file, but we will save a copy of this in the project folder, and we'll call that Rotary Flutes Toolpath. Hit save, and again we'll just close that now. Now another option we've got is the ability to set up vectors if we wanted to create a toolpath that's going to cut around our part multiple times. To do that, I'm going to set up another standard wrap job setup here again, taking the same parameters, and hit OK. I'm going to come up to Gadgets, Wrapping, and this time I'm going to look at Spiral Layout. If we click on that, you can see we've got an option to create a set of vectors that I could use perhaps to cut a barley twist with a pointed tool, or in this case I'm just going to cut a simple set of flutes again. I'm going to do 4 strands on this. I'm going to go with a spacing between the strands of 1 inch here, and again I'm just going to offset this from the start by 1 inch and from the end by 1 inch. I'm going to do a left hand twist, so we'll uncheck the right hand twist there, and I don't want to create any coves in this case. So you can see very similar to what we had before. Double check the values at the bottom, hit OK, and this is just again going to tell us or in this case it's going to tell us how many revolutions it will require to do this particular spiral based on those parameters. And now if we hit OK, it'll generate another set of vectors for us. Now if we hit F to fit, we can see these vectors are actually going off the edge of the part, and that's because the way this is going to be cut, in effect this edge joins up to the bottom edge when this is wrapped around. So these are just going to wrap round and around our cylinder to create a spiral set of flutes. So if we want to create a toolpath, let's go over to the Toolpath tab, select those vectors there from the 2D view, go to the 2D profile toolpath, and I'm going to take exactly the same values as I used before with the 1/2 inch ball nose tool and hit calculate there. Now there's no point me previewing this in a 3-axis environment because I'm only going to get a small piece of the toolpath in the 3D view. What I want to do in this case, if we just close that, is immediately go switch off the color shaded view, go to Toolpaths, Toolpath Drawing, wrap the Y values, and there again we can see what that looks like. If we want, we can switch on the material block to help us visualize how that's being cut, and we can see the tool entering and then just cutting around and around. And what's actually going to be happening there is the cylinder will be moving as the tool moves in a horizontal direction. So the tool will move horizontally, the cylinder will turn, and that's what's actually going to give us the spiral. Let's go ahead and save the file at this stage so you have a copy of it in the project folder. So we'll just call this Rotary Spiral Toolpath, hit save there. So these supplementary gadgets we've looked at are really about vector layouts. They're just about helping with certain specialist applications. It is important to remember though, you don't have to use these for wrapped rotary output. You can create any set of vectors you want, drawn in the software or imported, and you can use any combination of the toolpaths that are available in here as well, and all of those can be saved as wrapped rotary output too. There is one other gadget available specific for the rotary environment that is to help you shape your piece of material. So if you don't have a perfectly cylindrical piece to start with, then this can help you generate a toolpath that will allow you to get to that point so that you know you can safely run the toolpaths you've generated based on a particular size of cylinder. Let's take a look at that now. I'm going to come up to File and we'll close the file we're working on here. Now again, I'm going to come up to the Gadgets drop down and set up the same wrap job setup that we've been using before. And now I'm going to come up to Gadgets, Wrapping, and choose this Create Rounding Toolpath option here. Now we could either be starting with something that's almost round, or we can start with a square blank. In this case I'm going to assume we've got a square blank which is 3¼ inches across the flats. If we wanted, we could leave a bit of an allowance, a bit of extra thickness on our cylinder, but I'm going to go right down to our original cylinder size, and in this case I'm going to choose the option to do optimized raster machining so that it only puts the toolpath where it needs to in the corners here. Need to make sure we select a tool from the tool database. I'm going to choose 1/4 inch end mill for this, and we'll set the pass depth here to 0.25, hit apply and OK. We can give the toolpath a name, check the information is correct here, go ahead and hit OK. And we won't see much happen in the 2D view there, but if we look in the 3D view and we look from the side, we can see we've got a toolpath there that's been created. And if we go over the Toolpath tab, we can see that toolpath here in the list. Now at the moment that looks a little bit odd, but if we come up here, switch off our color shaded view again, switch on the material block, and then go to the toolpath drawing and once more wrap those around, now it's a little bit clearer how that's machining down the corners for us in this situation. So you can see there the toolpaths are deeper in the corners, it's machining around there to machine those corners down, and that will ultimately end up with a piece of stock which is 3 inches in diameter from a square block of material that's 3¼ inches across. Now if we switch the wrapping view off, so go back to wrapping off, it's important to look and see how the XY0 position relates to this as well. And really you can see XY0 is essentially where the middle of one of the flats of our square piece of stock is going to be. So I have to make sure that I set the XY0 position on my machine so that it was in the middle of one of those flat pieces of my material for this to work correctly. So that's just another one of these options that we have available to us when doing this rotary machining. Let's come up and save this file now so we have a copy of this too, and we'll call that Rotary Rounding Toolpath, and just save that in the project folder there as well. That almost concludes this tutorial. Let's just review a couple of key items to remember when doing rotary work. Firstly, make sure you use the wrapped job setup form in order to define the size of your job. That's also where you're going to indicate in which direction your rotary axis is oriented on the machine. Secondly, it's worth remembering that essentially the software is always working in a 3-axis environment. Although we have the ability to visualize the toolpaths in a rotary view, only when we actually save the toolpath using a post-processor that is configured correctly to do it will the data actually be turned into rotary output. And at that stage what's happening is the software is just taking the linear moves on that axis which is being wrapped around and just transposing those into rotary moves that are appropriate for your machine, assuming the post-processor is configured correctly. Thanks for watching this video.